This is hydrogen tap. What you're looking at here, another experiment, another test. I've got here a loop of tin. If you remember in the last few experiments, we noticed that a lot of the hydrogen was coming off the edge of objects. What I've done now is gone back to one of my original experiments back at about video 2 or 3, where I wrapped tin around a steel fitting. Produced a lot of hydrogen. What I've done here, if you can look here, you can see I have a plate submerged in lye, electrolyte. Doesn't have to be that big. I'm going to show you in a minute. And here's the tin. The tin is going to be on the minus side. The larger plate is on the positive side. As we know, the hydrogen is going to come off the minus side. So, I'm going to submerge this. I also have a amp meter here. And we'll take a look at that in a minute. So what I'm going to do is hook it up right now. We'll see what happens. Reading 0.24 amps. And there she is. Whether you can see that or not. The reason I made these loops like this is so you could see that it really doesn't care configuration, obviously. See if I can get a... Okay. Again, this is the minus side. There we go. There's my amps, 0.35, 0.34. See, the bubbles are really fine. I don't know what you can do with this. It's an interesting, dare I say, phenomena. See if I can get a better view of it. It's about as good as I'm going to get, I guess. I think one of the things I've been trying to prove all along is that all these videos that you're looking at, that I'm looking at, that are showing this tremendous amount of hydrogen that's coming up in very little amperage, 0.20, is a configuration, not a magical pulse system. It's just trying to figure out what creates the best hydrogen. I'm not convinced it is the pulse system that does it. There are many configurations that create more hydrogen with less amperage. Now there's only, about 12 inches of wire here, and you can see what's happening with it. Can you imagine if you configured this into something else? A couple of coils on it. What you could do. This is not an answer, this is just more information. There you go. One of the things people don't like us having is information. Information is power. As you can see, this should give a lot of you a lot of ideas, hopefully. Anytime you see something that's in a kind of same arrangement, don't look at it as the same. This is the way it works. It seems to be, at least to me, that it's the edge. We always have been talking about the edge as being the primary factor, but in with the edge comes the area. So there's a combination here. Now what I'm going to do is take the large plate out and put a smaller plate in for the positive. Plate I'm going to put in and use for the positive here. So it's a very small plate. I can get it on here. Okay. Now I'm going to put it on the positive side. See what happens. The interesting thing is it doesn't seem to care. Maybe it is. Of course, if I put this closer, let me put the bigger plate back in. It does care, obviously. Okay. Well, you see the size of the plate that I've got in there now. We're running 0.20 amps. This is on a 12-volt DC battery. So the next configuration you could conceive of would be to put a couple of spirals in there, hundreds of them, how's that? And to see how much hydrogen you can get out of it. Remember, what this is picture hanging wire. That's all it is. I get it for an electronic shop for ground wire, just very thin tin wire. You can get that anywhere. In itself, it's nothing. Configure this into something else. Let's say 100 strands of this, and you'd have a lot more hydrogen. It's at least something anybody can work with. You don't need any special lab for this. Of course, if you want to write me at johnaarons@hydrogentap.com, you can do that. Or go to my site, hydrogentap.com, and you can see what I have.